Again, students, it's me, Professor Childers. If you've been watching some of my videos, you hopefully have pulled a lot out of it. Today I'm going to talk about troubleshooting. Now, I have two basic circuits here. I have an electrical panel that's located here. I have a switch that's located here and a standard light fixture that's located here. Now, on the second circuit, I have a three-way switch, and a light fixture. So let's kind of go over what we have here. This is our electrical panel. Here's our meter. Here's our circuit breakers. This is our ground. So our green designates ground. Now, if we look at our circuitry going to our first circuit, you have a hot wire that comes off of a circuit breaker that goes to the switch. You also have a ground that goes to that box that the switch is in that continues on and goes to the light. Now the purple wire designates the neutral wire because I don't have a white marker, and if a white marker was drawn on here you wouldn't see it. So the purple wire indicates that this is the neutral. So in this group of wiring you have a hot, a neutral, and a ground. Then in this group of wiring here you have a ground, a switch leg, and a neutral. Now the red wire that's coming off of the switch is going to the light to turn it on. Now on our second circuit we have a hot wire, a neutral, and a ground coming into this three-way switch. And going from three-way switch to three-way switch we have a ground, a neutral, and two travelers. And then our final circuit that's going from the three-way switch to the light will have a neutral, ground, and a switch leg. Okay, so that designates what this drawing is all about. Now, for instance, let's say our circuit number 1 doesn't work. The light doesn't work. Okay, so what we want to do is we want to take our trusty multimeter and we want to go from the circuit breaker to the neutral. And we want to make sure that you have power coming off the circuit breaker. That's what's important, is to get the power off the circuit breaker to make sure you have a power source. Because once you have a power source, then you can follow it from there. The next step would be to check this group of wires here going to the switch. So what you would want to do is you would want to confirm that you have a hot line going to the switch, and you can either test that from the ground or the neutral to the hot wire going to that switch. Now, in the event that you have no power here, then there's a problem with this group of wires. Okay? Now, if you have power going to this switch and you don't have power going to this light, then what you want to do is check this group of wires. Quite possibly when you strip the wire, you nicked or broke or cut one of the wires. Now, if you have power going to this light fixture, then there's a good chance that the light fixture is bad. Okay? So that kind of gives you how you troubleshoot an electrical circuit. You always want to start at the power source. Then you want to move to the group of wires that's feeding your device or your control device. And then you want to go to the group of wires that's going to your device that's being controlled. Now, let's take a look at three-way switches just for a minute, because oftentimes three-way switches are very confusing. So again, we're coming off of a circuit breaker. You want to check to make sure you have power at the circuit breaker to the neutral or to the ground. Then you want to check these group of wires by going to the first three-way switch and see if you have power there. Now, in that three-way switch, you will have a neutral, you will have a ground, and you should have a hot wire. So you can test to see if you have power at that point right here by taking one lead of your multimeter to the hot and the other lead of the multimeter either to the neutral or to the ground. And you should check both of those, because if you have no neutral, then you have a problem in these group of wires coming from the panel. Alright, so you have power going to this point here, which is the first three-way switch. You want to check and make sure that this group of wires here is wired correctly. On a three-way switch here, you will have a black screw and two brass screws. Okay? The black screw is designed to be the hot or the switch leg. The two brass screws are designed to be the travelers. Oftentimes people miswire them or incorrectly wire them, and then they have all kinds of problems. Now, you want to check this group of wires here by checking this switch. Okay, so when this switch is turned on in one position, you should have a hot line here going to neutral or ground, or a hot line here going to neutral or ground. And that would be either one of the two brass screws on your switch. Or what you can do is you can take and go to the black screw on the three-way switch, the second three-way switch, to the neutral or the ground, and see if you have power. In the event that you don't have power and it's not wired correctly, that means that these travelers here are not wired correctly. Oftentimes people have a problem with wiring the travelers on three-way switches. Now, in the event that you have power here to the light fixture, but the light is not lighting, and you've checked the light bulb, oftentimes what happens is the center pin of a lamp holder will get bent, and you just turn the power off, take a little screwdriver and pull that little tab out so it'll make good contact. Now, if this is an outdoor light fixture like for a patio or a porch, the shell of this light fixture here, this little incandescent light fixture, is generally made of aluminum. And light bulbs are generally made out of aluminum or brass. In an outdoor application, what happens with this lamp holder here is it will get corroded. So a recommendation is to take high pressure water pump grease or some Vaseline, and you smear a little tiny bit around the shell of the lamp or the light bulb and put a little bit on the tip. That way when you screw it in, after a period of time it won't get corroded and you can unscrew it without the lamp breaking. A lot of times what people do is they'll screw that light bulb in so tight that when you go to remove it, it'll break anyway. But that's an old electrician's trick to put a little bit of lubrication on there. And believe it or not, Vaseline and water pump grease are not conductive. So you don't have to worry about a short on that. So getting back to everything, our panel is always grounded, and we either ground that by code to a water line or a ground rod for residential. For commercial, we generally ground it to the building frame. We can ground it to a ground rod, or we can use a UFR ground or a plate ground. Now, in Los Angeles County, I think the code book still says that you have to ground your electrical panel to a gas line. I wouldn't do that personally because gas is explosive. And you really don't want the ground wire to be a conductor unless there's a dead short. So if you have a dead short, it's going to go to the gas line, and you could have a potential problem. But everywhere else we're using ground rods, and we're using building grounds and structural grounds and cold water pipe grounds. Okay, so that basically tells you how to troubleshoot a circuit. Again, you start at your electrical panel and you go to your first group of wiring, because sometimes, you know, when you're installing wire from the panel out to wherever you're going to install it to, whether it's a room or an office or something like that, sometimes you end up pinching wires or cutting wires or taking the insulation off. The bad thing is in residential, a lot of times what happens is the guys that hang drywall sometimes can run a drywall screw right through your wiring. And when that happens, you've got to open up the wall and fix that. So again, thank you very much for watching. Have a great day.